Hello, my name is Joe, and this is JoeCoinMining. I'm a web developer and a blockchain developer, and in this video, I'll introduce to you the blockchain and explain the strict minimum you need to know in order to build applications on top of it. Blockchain is a special kind of database, and its main function is to store data. Like its name implies, a blockchain is a series of blocks of data. Block 1, Block 2, Block 3, etc. These blocks are linked to each other with cryptography. Block 3 refers to Block 2, which refers to Block 1, etc. That's why we call it a blockchain. In each block, there are two parts. The first, you have the metadata. In the metadata, you can find information such as timestamps at which the block was created, the reference to the previous block, and a cryptographic signature of all the transactions. And the other part of the block is transactions. Transactions describe how data changes. For example, for Bitcoin, a transaction describes how Bitcoin is transferred from an account to another one. The term transaction is a bit misleading here. The example I gave before is about a financial transaction, but actually, a blockchain transaction can describe a change of any kind of data, not only financial transactions. So you might think, okay, well, with these blockchain things, we have blocks and transactions, but this is just about the structure of data on the blockchain. But nothing is really revolutionary here. So what's the big deal about blockchain? Well, actually, there are quite a few important differences with traditional databases. So let's start with immutability. So with a blockchain, you can only add data to the database with new blocks, but you can never modify that data that is already in the blockchain. So the blocks that are already in the blockchain absolutely can't touch them. That's very different from a traditional database where you can change any data at any time. Let's talk about the blockchain network and the decentralized nature of blockchain. The blockchain does not run on one single computer, but instead it runs on a network of computers that are connected to each other. Each computer is called a node, and together they form a blockchain network. Anyone can run a blockchain node and be a part of the blockchain network. That's why we say that blockchain runs on a public network. There are already databases that can run on several nodes. We call these distributed databases. However, none of them run on a public network. They all run on a private network. So if anybody can run a node on the blockchain network, how can this network be secure? Well, for that, there is the mining process. If you want to add data to the blockchain, you need to add a new block to the blockchain with transactions that describe all the changes to the data that you want to bring to the blockchain. If you want to do this, you need to be engaged in a process called mining. Any node of the blockchain network can be a miner. When you are a miner, you compete with other miners on the network to solve a mathematical equation. The first miner that solves this mathematical equation has the right to add the next block to the blockchain. This mining process is described formally in an algorithm called proof of work. Without getting into details about proof of work, what's great about proof of work is that it's very difficult to hack, and it doesn't rely on any one centralized client party. So what are the pros of blockchain compared to traditional databases? Well, first, it's immutable, which means you cannot change any data once it's been added to the blockchain. Then, it's decentralized and censorship resistant. So a single actor cannot control the network. It's secure, especially thanks to the proof of work algorithm that is almost impossible to hack. But it also has some cons. Compared to traditional databases, first is much, much slower than a traditional database. Because you have to synchronize data across the whole network, that it usually is distributed globally. Another database disadvantage is that it's less scalable. So because you have to synchronize data across this whole network, the capability for this network to absorb more incoming transactions is much more limited than a centralized database. This problem is so important that actually the whole blockchain industry is focused on solving it. So you have many, many initiatives in blockchain technology to make the blockchain more scalable, such as Ethereum 2.0. Another disadvantage of blockchain compared to traditional databases is that it's much more expensive because you have to pay miners for the service of adding additional data to the database. So for this reason, we avoid to put too much data on the blockchain. And finally, because blockchains are public networks, absolutely no privacy. Any data that you put on the blockchain can be seen by anybody. So I'm aware that I'm going a bit fast on blockchain, but this course is not especially on the blockchain technology itself. It's more about building applications on top of blockchain. So if you are interested in how the blockchain works in detail, you can check out the white paper of Bitcoin that explains how the proof of work algorithm works. And that's a very central part of blockchain. I'll see you in the next video, which will be about cryptocurrencies and Bitcoin. Hello, my name is Joe, and this is JoeCoinMining. Today, we're going to be talking about Bitcoin and cryptocurrencies and how they work. When people hear the word Bitcoin, they automatically associate it to cryptocurrencies. But these are actually two different things, and it's important to understand the difference between cryptocurrencies and blockchain. So in this video, I'll explain the difference between cryptocurrencies and blockchain, and we'll also explain how cryptocurrencies like Bitcoin work. Blockchain is a technology. It's neutral. Depending on what kind of data you store in the blockchain, it can be used for a very different purpose. The most popular use of blockchain technology has been cryptocurrencies. There are many cryptocurrencies, as you can see on the website coinmarketcap.com. Bitcoin has a special place among cryptocurrencies because it's the first cryptocurrency that introduced the blockchain technology in 2009. So if you want to have a good understanding of how blockchain works, it's a good idea to study Bitcoin. Bitcoin allows the transfer of a virtual currency that we call Bitcoin between different addresses. Bitcoin addresses are identifiers composed of alphanumeric characters. Each of these addresses is associated to a Bitcoin balance. The owner of an address is able to spend his or her Bitcoin and send them to another address. The blockchain of Bitcoin records Bitcoin transfers in what we call transactions. These transactions are put inside blocks. These blocks are linked to each other, as I explained in the previous video about blockchain. If you want to compute the balance of a specific address, you have to go through all the blocks of the blockchain and take into consideration all the relative transactions. In Bitcoin, like for other cryptocurrencies, addresses are managed by external software that we call wallets. The blockchain itself doesn't have any centralized management of addresses. Everybody is free to create as many addresses as they want with their wallet. We'll see later in this section how we can avoid address collisions. New Bitcoins are regularly created by the blockchain to reward the miner who successfully add new blocks. This creation is not infinite, and it will stop at some point, which will limit the inflation of Bitcoin. Most people think that Bitcoin can only do financial transactions, but this is not actually technically true. Bitcoin can process slightly more complex financial transactions using what we call Bitcoin scripting, but that's not very powerful. Very few people use that, and generally speaking, it's not very easy to build blockchain applications on top of Bitcoin. That's it for this basic introduction to Bitcoin, and in the next video, we'll finally introduce Ethereum, an advanced blockchain that can do way more than Bitcoin can do. Thanks for listening. Hello, my name is Joe, and this is JoeCoinMining. Bitcoin was the first blockchain. It was really revolutionary. However, it was quite limited. That's why Vitalik Buterin decided to create Ethereum in 2013. Ethereum is a blockchain of second generation capable of not only processing simple financial transactions, but also any arbitrary computation. This allowed us to build much more sophisticated applications on top of blockchain. It's a little bit as if people were able to program their own bank account with JavaScript. So in this video, I will introduce Ethereum. At the very core of Ethereum, we have the same blockchain technology as in Bitcoin. In the Ethereum blockchain, we have a series of blocks. In each block, we have transactions. Ethereum used to have miners who added new blocks to the Ethereum blockchain using the proof of work algorithm. Ethereum initially used a proof of work consensus algorithm, which relied on miners to add new blocks to the blockchain. Miners would compete to solve complex mathematical problems, with the first miner to solve the problem being rewarded with newly minted Ethereum, ETH, and the right to add the next block to the chain. However, in December 2021, Ethereum underwent a major upgrade to Ethereum 2.0, which introduced a new consensus algorithm called proof of stake. Under this new system, validators instead of miners are responsible for adding new blocks to the blockchain. Validators are chosen based on the amount of ETH they hold and are willing to stake as collateral. They are incentivized to act honestly and maintain the network's security by receiving rewards in ETH for adding and validating transactions. The switch to POS is intended to be more energy efficient and secure than the previous POW system. We also have addresses. Each Ethereum address is associated to a cryptocurrency called Ether. And if you own an address, you can transfer your Ether to another address. However, on top of this basic blockchain technology, there is another part called the Ethereum Virtual Machine, or EVM. The Ethereum Virtual Machine is able to run small programs called smart contracts. Smart contracts can run code and manipulate Ether, the cryptocurrency of Ethereum. For example, with a smart contract, you can code a multi-signature wallet, where you need the approval of several persons before spending any Ether. The beauty of smart contracts is that their code is executed on the blockchain, so you don't need any third party to execute them. Once the code of a smart contract is deployed on the blockchain, nobody is able to change the code or stop the smart contract from running. It's just going to run on the blockchain forever. Another benefit of smart contracts is that it is very hard to hack them. Yes, I'm aware that some smart contracts were hacked, but it was always because of a bug in the code of the smart contract, but never because of the Ethereum technology itself. So I'm sure that by now you start to feel curious about these mysterious smart contracts. I will explain how they work later on in this section, but first we need to learn some basics of cryptography. So we're going to stop here, and in the next video, I'll teach you what a cryptographic hash is. Hello, my name is Joe, and this is JoeCoinMining. In this video, I will explain what a cryptographic hash is. Cryptographic hashes are used a lot in blockchain. For example, transactions are identified by hash, so it's important to understand what a hash is. A cryptographic hash is like a fingerprint. It uniquely identifies a piece of data. It usually looks like a gibberish string of characters. This gibberish in itself has no meaning. All we care about is that it uniquely identifies a piece of data. If we change just one character of data, the hash will be completely different. So how can we produce a hash? For that, we use a cryptographic hash function like SHA-256 or SHA-3. A cryptographic hash function will take any data as input and transform it into a fixed size cryptographic hash output. The size of the input data doesn't matter. The cryptographic hash will always have the same size. Another interesting property of hash is that a cryptographic hash function is a one-way operation. You can go from an input to a cryptographic hash, but you cannot go from a cryptographic hash to an input. That's interesting for privacy reasons. For example, If you want to represent some data on the blockchain, but you don't reveal what the data actually is, on Ethereum, the hashing function we use is called KSHAC-256. That's very similar to SHA-3, but there is a slight difference. If you want to dig into the detail, I'll put a couple of links in the video description. But as a developer who builds a blockchain application on top of blockchain, we don't really care how this cryptographic hash function works internally. What we care about is that they can produce cryptographic hashes that uniquely identify data. All right, so that is what cryptographic hashes are. We'll stop here. In the next video, we'll talk about transactions. Hello, my name is Joe, and this is JoeCoinMining. In Ethereum, the role of addresses is to send and receive Ethereum. It's very important to understand how they work. So in this video, I will explain what Ethereum addresses are. So we're going to start with how Ethereum addresses are created. First, we start with what we call a private key. That's a very long number that is generated randomly. It must be kept secret, like a password. So we have this secret private key. Then, by using what we call elliptic cryptography, we generate another long number called a public key. Elliptic cryptography is a very complex topic. But the point to understand as a blockchain developer is that you can go from a private key to a public key very easily, but not the other way around. This public key is 128 characters long, but we compute a cryptographic hash of this public key using the KSHAC-256 hash algorithm. So in other words, we compute a fingerprint of this public key. This fingerprint is a string that is 64 characters long. We take the last 40 characters. Finally, we prefix it with 0x. In the end, you have a string of 42 characters. That's your address. So now we have our address. What can we do with it? First of all, we can give it to anyone if we want to receive some Ethereum. And second, we can use the private key that we use to generate the address if we want to send Ethereum to another address. Technically, that's called to sign a transaction. And we'll see in details how it works later on in this section. But there's still one question. Where are these addresses created? Contrary to what you may think, it doesn't happen on the Ethereum blockchain. Instead, these addresses are created by external software called wallets. We'll stop here, and in the next video, I'll explain what a wallet is and how it manages addresses. Thank you. Hi, my name is Joe, and this is JoeCoinMining. In this video, I'll explain what a wallet is. A wallet is a software that manages addresses. This is different from the blockchain software. It's installed and controlled by users. There are different kinds of wallets. You can have desktop applications, mobile applications, browser extensions, and physical wallets. The most popular wallets used for Ethereum are MetaMask, a browser extension, and Nano Ledger, a physical wallet. We'll see MetaMask more in detail later on in this course. The first function of a wallet is to generate addresses. Like I explained in a previous video, wallets will first randomly generate a private key, then compute a public key, and finally derive an Ethereum address. For most people, one address is enough. Maybe you'll want to use one Ethereum address for saving your Ether and another for your current day-to-day operations. Fortunately, a wallet can generate multiple Ethereum addresses. You may think that a wallet will generate several private keys for that. Actually, no. A single private key is enough to generate multiple Ethereum addresses. Wallets that can do this are called hierarchical deterministic wallets, or HD wallets. Pretty much all wallets are like this. If you are interested in how this process works, you can check out the link to BIP 32 and BIP 39 in the video description. But the point to remember is that with a single private key, you can generate multiple Ethereum addresses from your Ethereum address. You cannot go back to the private key And also, if you take two Ethereum addresses, it's impossible to know that they came from the same private key. So that is good for your privacy. The creation of a Ethereum address is decentralized. Anybody is free to create as many addresses as they want. But how can we guarantee that two different people won't generate the same address? It's technically possible. If two different wallets generate the same private keys, then the same Ethereum addresses will also be generated. And one person will be able to steal the ether of another person. This is called an address collision. However, the likelihood that this happens is so low that you really don't have to worry about this. If someone steals your private key, he or she can steal all your ether. Physical wallets like Nano Ledger are safer to use in that regard, but they are less convenient to use. That's why usually people put most of their crypto savings in a physical wallet like Nano Ledger, and also keep a small buffer in a software wallet like MetaMask for current operations. If you lose access to your wallet or it breaks, you also lose access to your private key, and you'll be unable to spend your ether. So that's why it's recommended to do a backup of your private key. And the safest way to do this is to copy your private key on a piece of paper. So copying the private key directly won't be very convenient because this is a very long number. So instead, wallets give what we call a mnemonic phrase. Mnemonic phrase represents your private key with 12 words. It's much more user-friendly to manipulate this. Besides creating addresses, the other function of a wallet is to sign transactions using your private key. That's what allows you to send your ether, and we will see this in the next video. Thanks. Hi, my name is Joe, and this is JoeCoinMining. In this video, I'll explain Ethereum transactions. A transaction is a signed package of data that describes an action that you want to take on the blockchain. You can have three types of transactions. First, you can send ether to another address. Second, you can execute a smart contract. And third, you can create a new smart contract. Let's see what are the different fields of a transaction. First, you have the from field. That's the address that sends and signs your transactions. Then you have the to field. That's the recipient of the transaction. If you send some ether to someone, well, that would be the recipient address. If you execute a smart contract, that will be the address of the smart contract. And if you create a new smart contract, this will be empty. Then you have gas and gas price. So I will explain what gas is later on in this section. But very briefly, this describes how much you are willing to pay the miners in order to include your transaction on the blockchain. Then you have the value field. So you will fill it only if you want to send some ether to someone else. Then you have the data field. So this is used if you want to call a function on a smart contract. You will describe what function you want to call and with which argument. And then you have the nonce field. That's optional. And this allows you to override a previous transaction. So next, let's see what is the life cycle of a transaction. First, your wallet builds a transaction. So it's going to fill all the fields I described before, from, to, etc. Then the wallet will sign the transaction by using the private key associated to your address. Then the wallet will send a transaction to the Ethereum blockchain. The miner will pick up your transaction and include it in the next block. This process takes about 15 seconds. One thing very important to understand here is that it doesn't matter who delivered this transaction to the Ethereum network, because if anybody tried to change the content of the transaction or modify the signature, the Ethereum blockchain will pick up the fact that the transaction is invalid and it will be rejected. After a transaction is processed by a miner and included in the block, you'll be able to see the side effect of the transaction. So if you send some ether, you will see the updated balances. If you execute the function of a smart contract, you will also be able to see the updated data. And then you can inspect the transaction actually took place by using the Blockchain Explorer. And for Ethereum, the most famous one is called Etherscan. And we'll see more in detail later in this course. So in this video, I mentioned a lot about smart contracts. And I'm sure by now, you'll start to feel really curious about these mysterious smart contracts. So we'll stop here, and in the next video, I'll finally introduce Ethereum smart contracts. Hi, my name's Joe, and this is JoeCoinMining. In this video, I'll explain what smart contracts are. Smart contracts are really what makes Ethereum so special. So it's very important to understand how they work. A smart contract is a small program that runs on the Ethereum blockchain. Smart contracts have some properties that make them very different from other programs. Let's start with the pros. Their code is immutable. Once you deploy a smart contract to the blockchain, it's impossible to update it. So you'll have a guarantee that the code will run exactly as it was deployed. Smart contracts are censorship resistant. Once you deploy them, no government or organization can stop them, not even the creator of the smart contract. Smart contracts don't require to run on any server. You can just deploy them to the blockchain and forget about them. Smart contracts are very safe if they have no bug in their code. It's almost impossible to hack them. Smart contracts can natively transfer Ether, the cryptocurrency of Ethereum. In other applications, if you want to manipulate money, you have to do complex integrations with payment processors like PayPal and Stripe. And that's not ideal. With Ethereum, it's very simple. So these are pros, but there are also a couple of cons and limitations. Let's see them. First, it's expensive to run smart contracts. You need to pay with something called gas. And we'll look into this further in the next video. Smart contracts are very slow. When you want to interact with the smart contract, you need to send a transaction and wait for this transaction to be picked up by a miner. It takes on average 15 seconds. Smart contracts have very limited capabilities compared to other programs. For example, you can install too much data into them, and you can't run any computation that is too complicated. Also, you can schedule a smart contract to run in the future like you would with a cron job. And finally, with smart contracts, you cannot call any API that is outside the blockchain. Next, let's see how this works. A smart contract has an Ethereum address, some code and some data, and they run on the blockchain. First, you need to write the code of your smart contract. And you can use a programming language like Solidity for that. In Solidity, you define variables and functions like you would do with any programming language. Then you need to compile this code into what we call an EVM bytecode. The EVM, or Ethereum Virtual Machine, is the part of Ethereum that runs smart contracts. The EVM doesn't know how to run Solidity. It only knows how to run some elementary instructions. The EVM bytecode is a series of these elementary instructions. So once you've compiled your smart contract and you have this EVM bytecode, you need to create your smart contract on the blockchain. For that, you create a transaction with the EVM bytecode and you send it to the blockchain. The miner will pick up the transaction and the smart contract will be created. After that, you can interact with your smart contract. To do that, you will create other transactions, where you specify which functions of the smart contract you want to call. Maybe there is some function, it will send some ether to other addresses, perform some computations, and the function can even call a function on another smart contract. That means that a smart contract can execute some other smart contract in the blockchain. And that is very, very powerful. So I'm sure at this point you still have a ton of questions about how smart contracts work. And later in this course, we'll see this in more detail when I teach you how to code smart contracts with Solidity. But for now, we'll stick with this high-level explanation. In this video, I mentioned something called gas. That's something important to understand, and that's what we'll see in the next video. Hi, my name's Joe, and this is JoeCoinMining. In this video, I will introduce gas. When you send a transaction to the Ethereum blockchain, you need to pay for transaction fees. That's because we want to prevent spamming, and we also want to reward miners for their efforts. So who pays what and to who? First, who pays? The sender of the transaction. When I say sender, I actually mean the address that signed a transaction. It doesn't matter who delivers the transaction to the network. It could be the signer of the transaction or anybody else. Who receives this transaction fee? You can't know this in advance, but it will be the miner that successfully mined the block, in which your transaction is included. And last question, how much will you pay? For that, we need to understand gas. When you run a smart contract, you run some elementary operations on the Ethereum virtual machine, what I called before the EVM. Each of these elementary operations is more or less computationally intensive, and we quantify this with gas. Maybe that's an addition, it will be 10,000 gas. Saving some data will be 20,000 gas, etc. So we add the gas cost of all these operations, and at the end, we have a total gas cost. Then we need to convert this gas cost into Ether, because we're going to pay the transaction fees in Ether, not gas. Gas is just an abstract unit to measure a transaction fee. But you can actually pay with gas. To get this conversion from gas to Ether, we need to know how much Ether you are willing to pay for each unit of gas. That's what we call the gas price, and it's actually up to you to decide this. If you put a gas price too low, the miners will not be interested and will ignore your transaction, and it will never be mined. If you put a normal gas price, your transaction will most likely be mined in 15 to 50 seconds or slightly more. And if you are really in a hurry, you can put a higher gas price, and your transaction will be mined faster. You can check out the average gas price used on the network on a website called ETH Gas Station. So let's go back to the gas fields of a transaction. So you have gas and gas price. For gas price, I already explained. For gas, that's the maximum gas cost that you are willing to pay for this transaction. It's actually possible to simulate a transaction and have an estimate for this gas parameter, and usually wallets do this for you. So most of the time, you don't have to deal with this. That's pretty much all you need to know for now. If you want to dig deeper on this topic, I have a longer explanation on my YouTube channel. I'll put the link in the description of this video. I'll stop here, and in the next video, I'll explain what are the differences between the different Ethereum networks. Thanks.